All right, welcome back to a book reading video. I've got other series going, but this is the one I'm focusing on now. This book has been really valuable, so we're gonna keep going through. The next section is going to be working with Bash and ZSH. Before I move on, though, I do this a lot. I kind of get distracted, but this is going to be a really good distraction here because I have a home lab that I switched over to Ubuntu server recently, so I could run KVM virtualization on it. So if I can SSH to it, I think it's .8. I'm not even sure. Oh, right, and then I need a terminal that has SSH. Okay. Oh, I don't remember. Okay, there we go. So what I'd like to do is install htop on there. Oh, it already had htop. Cool. That's really cool. Okay, yeah, it already had htop. So we learned about htop last time. Let's filter this. Let's sort this by user, because I see there's other users on there. Yeah, so we got a lot going on this thing. It's a server hosting a lab, so looks like we got root is doing stuff. Oh, it's running the Docker containers. We got syslog running. Yeah, so cool. It's already on there. All right, so let's not waste any time and let's read about working with Bash and ZSH. It all starts with customization. Both Bash and ZSH will usually come with a file, a file prefixed with a that holds configuration, but by default is hidden when directory contents are listed and lives in the home directory of the user. For Bash, this is .bashrc. For ZSH, this is .zshrc. Okay, so let me pull up my lab before I continue. And hopefully that virtual machine that I was working on before still has everything on it. Probably does not though, but we will see shortly enough. Alright, so while that's loading I can keep reading. Both shells support several layers of places that will get loaded in a predefined order, which ends in the configuration file for the user. When ZSH is installed, a .zshrc is usually not created. This is how a minimal version of it looks in a CentOS distro. All comments removed for brevity. So this I'm gonna wanna do. So I might have to, install apt-get install ZSH. Okay, my lab is finally loaded up though, so I just need to start the VM, which usually doesn't take too long. Okay, that doesn't take long. And then I'll have that up like this. So we'll skip that for now. Bash has a couple of additional items in it, but nothing surprising. You'll no doubt get to the point of being extremely annoyed at some behavior or thing you saw in some other server that you want to replicate. We can't live without colors in the terminal, so whatever the shell, it has to have color enabled. Before you know it, you are deep into configurations and want to add a bunch of useful aliases and functions. Soon after, the text editor configurations come in, and it all feels unmanageable on different machines or when new ones are added and all those useful aliases are not set up, and it is unbelievable. But no one has enabled color support anywhere. Everyone has a way to solve this problem in an entirely non-transferable ad hoc way. Alfredo uses a makefile at some point, and his coworkers use either nothing at all or a bash script. A new project called .drop has lots of features to get all those dot files in working order, with features such as copying, symlinking, and keeping separate profiles for development and other machines. Pretty useful when you move from one machine to another. Okay, so we're going to learn about that. Right now, let's go back and we'll run this file here. And I don't have this, so we'll just see it fail. Okay, no such file or directory. Another thing I want to do is I'm going to have another shell open. So just a PowerShell. Yeah, and then we're going to SSH to my home lab because some of these things I want in my home lab. Oh, this doesn't have SSH either. Alright, so, yep, that looks good. Next step is going to be seeing if I can cat this out on my home lab, because I have a fairly recent distribution of Ubuntu server on here, so some of these things might already be available. But it looks like this ZSH is not available on Ubuntu server, at least the version I have, without installing it extra. But for now, just because we're just learning about it new and playing around with it, and we want to break it, we want to be able to back out from a mistake, we're going to install it only on this machine first, this virtual machine that I can just blow away if I do anything wrong. Let's see if I've got internet. I'm pretty sure I do. Yeah, I've got internet. What if I get, what if I just Google for it like I did before? Yeah, that's been the way to do it. Oh, maybe because it's not, yeah, maybe because I didn't update. Like, I think, when I stop it, like, I don't have htop anymore. Oh, no, I do have htop. Okay, so it persisted. I was going to say maybe the state didn't persist. Sometimes with a VM, you've got to take a snapshot of the state of the VM, otherwise it'll wipe itself out. Okay, now it seems to be working. It's just because I didn't have apt-get updated. Oh, no, it's not. It's not. It still can... Oh, sorry. It's because I have a second sudo in there. So let's get that out of there. Try this again. Update should go faster. There we go. Update went a lot faster. Okay, now it found it since it's updated. It was just out of date. All right, so hopefully, and I can close this now. I'll come back to it later and add it if it's sticks in my mind enough. If it doesn't stick in my mind enough, then it's probably not something I need to add anyway. Okay, so we still don't have this file. It's usually not okay. What's ZSH? I've never used that before. Ignore insecure directories and files. No, let's not ignore the insecure ones. Oh! Okay, well, let's hit W, because clearly... Alright, I'm not sure what's going on here. Let's just keep going. You can use -drop for a Python project, and although you can install it via the regular virtual env and pip tooling, it is recommended to include it as a submodule to your repository of .dot files. If you haven't done so already, it is very convenient to keep all your .dot files in version control to keep track of changes. Alfredo's .dot files are publicly available, and he tries to keep them as up-to-date as possible. Independent of what is used, keeping track of changes via version control and making sure everything is always updated is a good strategy. That's awesome, yeah. So if I'm on the job and I don't like how they're handling Vim, I don't like how they're handling ZSH, Get, whatever have you, I can keep my own .dot files on my own repo and just pull it in and in my own files, overwrite whatever, or just include this and use this. So this is a really good idea. Yeah, unfortunately, I'm not going to just copy his over. I'm not going to do this until... I'm tempted to just make a, like an empty repo for this, but I'm not going to do this until it makes sense. Yeah, I don't need to do this yet. Okay. I would like to try to get .drop though. Yeah, let's try to install .drop. Okay, unable to, maybe because it's got a capital D. No. Okay, yeah, .drop seems kind of interesting. I think you have to get it, so it actually did have some text. So, yeah, down here, you can use .drop for a Python project, and although you can install it via the regular venv and pip tooling, it is recommended to include it as a submodule to your repository of .dot files. Oh, okay. I know what they're saying. This is not clear for beginners. I mean, this book really isn't for beginners. It's a little bit over my head, but I can translate what they're saying. So what they're saying is, what you can do is you can do this. So this is what I know how to do. we're going to activate the virtual environment, source venv, bin, because we're on Linux, activate. And now I can do a pip install .file. So that's one way to do it, but the problem is if you do it that way, you're not you need to do another step. You need to go and bring in your .files. So a better way to do it is to have it in your Git repo where you want your custom .files, and then when you pull in your .files, you pull in that module as well. And that's what Alfredo is doing. So if we look in his .files repo, we'll see, so we see .drop here. I'm not sure what this arrow means, and I'm not sure why I can't open it. Yeah, I'm not sure what this arrow means. I've never seen that before. But this is the .drop module, the same thing I installed here using a virtual environment and using pip install. He just included it in his repo where he's got his custom .files. That's a better way to do it. So then you just in one step, you bring in all your .files, you're all good to go. You don't have to do a pip install and then you don't have to do it in 2 steps that way. It's more convenient if you just include it in your repo of customizations. Okay, so independent of what is used, keeping track of changes via version control and making sure everything is always updated is a good strategy. Alright, I'm going to take a quick break. I'll be right back. Alright, I'm back. So next part is customizing the Python shell. You can customize the Python shell with helpers and import useful modules in a Python file that then has to be exported as an environment variable. I keep my configuration files in a repository called .files. So in my shell configuration file, $home/.zshrc for me, I define the following export. So that's in his file. We don't have that file, so okay, he's going to tell us how to try this out. So to try this out, create a new Python file called pythonstartup.py, although it can be named anything, that looks like this. So let's follow along here. So we'll do nano python startup.py. Import types, import UID, others equals types dot module type, others Alright, so that's all there is to it. I will exit and save. Now open up a new Python shell and specify the newly created python startup.py. Okay, so python startup equals python startup.py python. Okay. Now let's try helpers. Module helpers, okay. The helpers object is immediately available. Since we added the UUID4 property, we can access it as helpers.uuid4. As you may be able to tell, all the imports and definitions are going to be available in the Python shell. This is a convenient way to extend behavior that can be useful with the default shell. So helpers.uuid4. I'm not sure why we would use the default shell though. Like I'm going to be using ipython whenever I use the shell. Oh. Alright, so recursive globbing. Recursive globbing is enabled in ZSH by default, but Bash versions 4 and higher requires shopt to set it. Recursive globbing is a cool setting that allows you to traverse a path with the following syntax. Let's see if we've got recursive globbing. Oh, it worked. Now let's try installing apt-get install shopt. Okay, I couldn't find it. That snippet would go through each file and directory recursively and list every single file that ends in .py. This is how to enable it in Bash 4. Okay, so that's worth a highlight, I think. We're going to highlight this. Alright, so searching and replacing with confirmation prompts. Vim has a nice feature in its search and replace engine that prompts for confirmation to perform the replacement or skip it. This is particularly useful when you can't nail the exact regular expression that matches what you need, but want to ignore some other close matches. We know regular expressions, but we've tried to avoid being an expert at them because it would be very tempting to use them for everything. See, that's where I'm at too. Most of the time you will want to perform a simple search and replace and not bang your head against the wall to come up with the perfect regex. The C flag needs to be appended at the end of the command to enable the confirmation prompt in Vim. Alright, so let's give this a shot. I'm not sure what this is here, but we'll try just typing it into Bash. So this right here, hitting enter, this is a Bash shell. If I do ipython, this is a ipython shell. If I quit and I type in Python, this is just a regular Python shell. So just because I'm not in a Python shell does not mean I'm in a shell. That doesn't, yeah, so as long as you're, like, this is a shell, like just something that allows you to type things in, and this here is a Bash shell. So I kind of had to learn that it's often not clear that you're actually in some kind of version of a shell or what it's called. Like, it doesn't say Bash anywhere, but you can yeah, so you can type in Bash and then it takes you to the same thing. So you can open a new Bash shell. All right, but let's keep reading here. So, actually, let's see if we can get. Yeah, let's open up Vim. Oh, maybe Vi. Pattern not found. Yeah, I don't think it's going to find it because I don't have any text. It's just a blank file. The above translates to search for original term in the whole file and replace it with replacement term. But at each instance, prompt so that one can decide to change it or skip it. If a match is found, Vim will display a message like this one. Replace with replacement term, and then a whole range of options here. The whole confirmation workflow might seem silly, but allows you to relax the constraints on regular expression, or even not use one at all for a simpler match and replace. A quick example of this is a recent API change in a production tool that changed an object's attribute for a callable. The return code, code returned true or false to inform if superuser permissions were required or not. The actual replacement in a single file would look like this. Okay, yeah, this is highlightable for sure. That'll come in handy sometime. It's a good takeaway from this book. The added difficulty here is that needs underscore root, which is the original term, and then it's going to be replaced, was also spattered in comments and doc strings, so it wasn't easy to come up with a regular expression that would allow skipping the replacement when inside a comment block or in part of a doc string. Oh really? I would think it would be. That wouldn't be too hard to, because you could just do a pound sign if it's Python, and then a asterisk, so any 0 or more times, and then a dot with another asterisk. I think you could just do that. With the C flag, you can just hit Y or N and move on. No regular expression needed at all. With recursive globbing enabled, shopt-s globstar in bash 4. This powerful one-liner will go through all the matching files, perform the search, and replace the item according to the prompts if the pattern is found inside the files. So we're not going to follow along with this one. We've got the regular here, so. There is a lot to unpack here, but the above example will traverse recursively to find all the files ending in .py, load them into Vim, and perform the search and replace with confirmation only if there is a match. If there isn't a match, it skips the file. The set event ignore minus equals syntax is used because otherwise Vim will not load the syntax files when executing it this way. We like syntax highlighting and expect it to work when this type of replacement is used. The next part after the pipe character is the replacement with the confirmation flag and the E flag, which helps ignore any errors that would prevent a smooth workflow from being interrupted with errors. Alright, tip. There are numerous other flags and variations that you can use to enhance the replacement command. To learn more about the special flags with a search and replace in Vim, take a look at :help substitute, especially at the S flags section. So I wonder if I have that. I'm not running Vim, I'm running Vi, so let's see if I have :help substitute. Oh, I do. Okay. Oh, yeah, up here. I've got help. Okay, so all right, moving on. Make the complicated one-liner easier to remember with a function that takes two parameters, search and replace terms, and the path. Name it VSED as a mix of Vim and the SED tool so that it is easier to remember. In the terminal, it looks straightforward and allows you to make changes to multiple files easily and with confidence, since you can accept or deny each replacement. So we can Yep, move that all the way up through all the files. Okay, moving on. Next section is removing temporary Python files. Python's PYC and more recently its PyCache directories can sometimes get in the way. This simple one-liner alias to pyclean uses the find command to remove PYC and goes on to find PyCache directories and recursively deletes them with the tool's built-in delete flag. Oh yeah, heck yeah, I'm definitely highlighting this. That's awesome. Alright. Alias pyclean equals find dot backslash and then another backslash. Now, is it typed or is it type D? I think it's type space D because it was type space F. Oh yeah, so this is if it's a directory with the name PyCache. PyCache is a directory. The PYC are files. Okay, so let's try the alias now. Oops, the alias is named pyclean. You have too many, okay, so where's the extra one? That was for find. I have too many. Really? I don't have any. I only have... Seems fine to me. I only have two of them, open and closed. Is two too many? I don't think two is too many. It looks fine to me. I think they're lying. You have too many parentheses. No, I don't. I only have two of them. I have one here. Maybe, what if I just get rid of that one? Okay, now I don't have any end parentheses. Okay, this is not working for me. This is cool, but Unfortunately, it's not working. I'm not sure what's going on here. I'm kind of tempted to remove my highlight because it didn't work, but that's okay. We'll just leave the highlight and keep going. Listing and filtering processes. Process listing to view what runs in a machine, and then filtering to check on a specific application is one of the things that you'll do several times a day at the very least. It is not at all surprising that everyone has a variation on either the flags or the order of the flags for the PS tool. We usually use AUX. It is something you end up doing so many times a day that the order and the flags get ingrained in your brain, and it is hard to do it any other way. It's a good starting point to list the processes and some information, such as process IDs. Try this. Alright, so we're going to try that. I wish that alias worked, but whatever, we're moving on. Okay. This command lists all processes with the BSD -style flags, flags that aren't prefixed with a dash, regardless or whether they have a terminal TTY or not, and includes the user that owns the process. Finally, it gives more space to the output W flag. Most of the times you are filtering with grep to get information about a specific process. For example, if you want to check if engine X is running, you pipe the output into grep and pass engine X as an argument. That is great, but it is annoying to have the grep command included. This is particularly maddening when there are no results except for the grep. Okay, let's try these commands. I don't think I have nginx running, so we won't get anything, but we'll try it. Oh, I do have nginx running. Okay. All right, so let's try the next command. All right. No Apache process is found, but the visuals may mislead you to think. Oh, I see. Yeah. So that's exactly what happened. I did this ps.aux grep, and I believed there to be an nginx running. I did it for Apache. I believed there to be nginx running. But what was running is neither nginx nor Apache. What was running was bash, the command I entered here. So that's what I got back. We can see here that at the time of running this command, I'm running this command. So I'm not running Apache, I'm not running nginx, I'm running grep. So it shows up there. So no Apache process is found, but the visuals may mislead you to think it is. And double checking that this is indeed just grep being included because of the argument can get tiring pretty quickly. A way to solve this is to add another pipe to grep to filter itself from the argument. Okay, this is worth a highlight as well. All right, and let's see that now. So we're going to do ps auxw pipe grep Apache, but now we're only interested in whether or not Apache is running, not whether or not we're running the grep command. We know we are. So we'll do another grep, but now instead of matching for something, we're going to do this -v flag, which means if you see something, don't include that line. So we're going to look for the word grep. If it sees grep, don't include that line in the output. And now we get nothing because I truly am not running Apache. I think I can probably run it. If I just, oh, no, okay. To have to always remember to add that extra egrep can be equally annoying. So an alias comes to the rescue. Oh, yeah, I'm gonna get rid of this highlight. And I'm gonna just highlight the alias. There we go. Yeah, any alias they give, I think yeah, I've got this one highlighted too, perfect. Okay, so let's make an alias, and we'll see how much easier it is to check the processes on this machine. Okay, and then $1. I'm not sure what the $1 means. Okay, so we can see our bash shell's running. The new alias will filter the first grep line out and leave only the interesting input, if any. Unix timestamp. To get the widely used Unix timestamp in Python is very easy. So we'll open up ipython. We can see that they've got an ipython shell open in this example because of this syntax here. So let's import time. Okay, and then let's get that Unix timestamp. But in the shell, it can be a bit more involved. This alias works in OS X, which has the BSD flavored version of the date tool. OS X can be awkward with its tooling, and it may be confusing to never remember why a given utility, like date in this case, behaves completely differently. In the Linux version of date, a far simpler approach works the same way. Oh. Wait, no, it should be an alias. Why is it not defined? Oh, because I did it in Python. It has to be done in bash. So to get to bash, I just exit out of Python, and now I'm in bash. I can also open another bash shell by going like that, but we're gonna stay in the original bash shell. So, and then we'll make an alias. Okay, so now I've got a timestamp. Okay, and I'll save this highlight as well. All right, next part is mixing Python with bash and ZSH. It never occurred to us to try and mix Python with a shell like ZSH or bash. It feels like going against common sense. But there are a few good cases here that you can use almost daily. In general, our rule of thumb is that 10 lines of shell script is the limit. Anything beyond that is a bug waiting to make you waste time because the error reporting isn't there to help you out. Random password generator. The amount of accounts and passwords that you need on a week-to-week basis is only going to keep increasing, even for throwaway accounts that you can use Python for to generate robust passwords. Oh. Yeah, that sentence is like messed up. The amount of accounts and passwords that you need on a week-to-week basis is only going to keep increasing, even for throwaway accounts that you can use Python for to generate robust passwords. Create a useful randomized password generator that sends the contents to the clipboard to easily paste it. Okay, so let's try this. We'll open our ipython shell again. Import OS. Oh. I should install... Oh. Okay, let's just keep going. I'm seeing an error message or warning message. Okay, so let's import base 64, and we'll print base 64 b code os.u random 64 decode utf-8. Porting that to a shell function that can take an arbitrary length. Useful when a site restricts length to a certain number. Looks like this. Okay, so we're going to port that to a shell function that can take an arbitrary length. Alright, let's try that. Oh, this is okay. Okay, I don't know. Oh, okay. We'll do this on another line. There we go. Oh, and then we need another line still. We need echo Yeah. Oh, god damn it. Invalid syntax? What's invalid about it? Oh, something's invalid here. Oh, I see what's invalid. Oh, wait, no. Yeah, that's fine. Huh. Yeah, this doesn't appear to be closing. Like this first symbol here doesn't appear to be closing. That looks okay. This needs to be double quotes. That's not what it says in the book, but I'm pretty sure it has to be that way. Or wait, no, it doesn't. God damn it. It doesn't, because there's backslashes. Because there's escapes, it doesn't have to be like that. Huh. I don't understand why it's invalid syntax. It seems like it's valid syntax. Do I need to do this? No. Why is it invalid syntax? It doesn't seem like it is. $sign. Yeah, it's not invalid syntax. It's exactly what they have here. I guess it's a little bit concerning that this is a different color. This should be green, right? Yeah, I'm not sure what's going on. Maybe I have like a different version of shell, or oh god damn it, I'm in the wrong shell. I've got to be in a bash shell. I was in a Python shell. Okay, I'm gonna put this in Notepad++. There we go, and I'm gonna take this out. Okay. Alright, and now it should work, since this is valid bash syntax, it's not valid Python syntax. Boom! Okay, now it works. And I like how bash tells you, like, what you're doing. Like, that's pretty nice. Okay. Now the mpass function defaults to generate 12-character passwords by slicing the output, and then sends the contents of the generated string to xclip so that it gets copied to the clipboard for easy pasting. Note, xclip is not installed by default in many distros, so you need to ensure that it is installed for the function to work properly. If xclip is not available, any other utility that can help manage the system clipboard will work fine. Okay, so let's see if it works. It might not work because I don't have xclip. Oh, do I need to pass it something? There's nothing in my clipboard, it's just the same function in my clipboard. My clipboard didn't get overwritten. Okay, well maybe that unknown. Let's try installing xclip and then rerunning it. Nope, still didn't work. My clipboard hasn't been overwritten. Okay, so I'm not sure what's going on there. Oh, you know what? Maybe because I overwrote it with. No, it's still not working. Yeah, I don't know what's going on. Let's just. I mean, to get a secure password, you don't like. There's any number of ways. So, does my module exist? Find out if a module exists, and if it does, get the path to that module. This is useful when reused for other functions that can take that output for processing. Okay, let's try this. I wonder if it's because, let me try deactivating my virtual environment. Okay. See, I don't know. Well, okay. Well, let's pass it. Let's pass it an argument. So we're gonna do try, and then we're gonna look for the requests module. Oh, okay. So I was trying to do it as if it were Python. In Bash, when you define a function, you pass it arguments just by doing a space, which makes sense because that's how you run a Python shell with spaces. So so if I want to see if I have requests installed. I don't have it. If I want to see if I have sys installed, I don't have it. Let's try, I should have sys. What's another one? Math. Let's see what we got the math module. Okay, yeah, I don't like this script. I'm not gonna bookmark this one. I mean, it's nice to tell, which modules you have installed, but to do that, I prefer to do this. You open a Python shell, you do help, and then you type in modules, and then I think that's a better way to tell which modules you have installed. Alright, so changing directories to a module's path. Where does this module live is often asked when debugging libraries and dependencies, or even when poking around at the source of modules. Python's way to install and distribute modules isn't straightforward, and in different Linux distributions, the paths are entirely different and have separate conventions. You can find out the path of a module if you import it and then use print. Oh, that's nice. I didn't know that. Alright, I'm definitely keeping track of this. I'm highlighting this. This is really helpful. It isn't convenient if all you want is the path so that you can change directories to it and look at the module. This function will try to import the module as an argument, print it out. This is shell, so return doesn't do anything for us. And then change directory to it. Okay, so let's try this bash script they've got here. So we've got to go to our bash shell, clean up the output in the terminal. Okay, I'm not seeing. Okay, so the accept's there. This indentation is really bad because it has to be the same. It has to be indented at the same line as this import statement. Okay, and we want Okay, we've got our, okay, so let's make it more robust in case the package name has a dash and the module uses an underscore by adding this. So we're going to do module equals ICD If the input has a dash, the little function can solve this on the fly and get us to where we need to be. All right, let's try this. CDP, QG resources. And it looks like I just made a typo here. I forgot. Oh, never mind. I don't have this module. Or something happened. Okay, but we'll just skip this. I'm not sure what they're getting at here. This doesn't seem relevant. I'm not going to highlight this. So let me make sure I'm where I am. And then, yeah, so this one I am going to highlight because that's cool to know the path that way. But let's keep going. Converting a CSV file to JSON, Python comes with a few built-ins that are surprising if you've never dealt with them. It can handle JSON natively, as well as CSV files. It only takes a couple of lines to load a CSV file and then dump its contents as JSON. Use the following CSV file, addresses.csv, to see the contents when JSON is dumped into the Python shell. So we're going to go with our own CSV file. Let's just we'll type in random large CSV file. Yeah. So we'll generate a random CSV. Okay. So there we go. So, yep, we'll save as, download. You know what? This is actually, we want this in a virtual environment, so we'll just copy the clipboard, go over, and we'll make sure to name it the same. So it's going to be named, oops, what is it going to be named? I don't even know. Addresses.csv. Oh, I forgot to hit I. God damn it. Okay, that looks good to me. There we go. All right. So we're going to do import. Oh, we'll open it. It looks like they don't have a ipython shell open for some reason, but we will definitely use one. And the CSV module, if we print that out, there we go. We'll do that with the JSON module as well. Just because I didn't know you could do that. All right, so contents equals open addresses.csv read lines json.dumps list csv reader contents. And there we go. We've got a JSON payload where each row of content in our CSV file is in its own list. So we've got a list that contains lists where each element in the list is a column and then each list is a row. So you've got, yeah, okay, wow, that's actually pretty useful. You know what? I'm highlighting this. I'm highlighting this whole thing. Okay, so port the interactive session to a function that can do this on the command line. Okay, so let's try that. Okay, let's try that. So we're gonna make a bash script. Ow. The tip of my finger started hurting randomly. Okay, so use it in the shell, which is much simpler than remembering all the calls and modules. Okay, so let's try to use it in the shell. Didn't work. Okay, we got an error here. While passing the string literal. Oh, it's gonna be on the same line. Okay, now it should work. Perfect. Boom, I like this. I like this a lot. This I like. Alright, next section is Python one-liners. In general, writing a long single line of Python is not considered good practice. The PEP 8 guide even frowns on compounding statements with a semicolon. It is possible to use semicolons in Python, but quick debug statements and calls to a debugger are fine. They are, after all, temporary. Alright, so debuggers. A few programmers out there swear by the print statement as the best strategy to debug running code. I'm probably one of them. I use prints all the time. In some cases, that might work fine, but most of the time we use the Python debugger with the PDB module, or ipdb, which uses ipython as a backend. By creating a breakpoint, you can poke around at variables and go up and down the stack. These single line statements are important enough that you should memorize them. Set a Okay, I'm gonna do Okay, I'm gonna highlight this. So this I recommend that you memorize. So this is setting a breakpoint and drop to the Python debugger PDB. So let's open up ipython, and then we'll do import pdb, oops, and then in another line, which we're gonna tell the shell we're doing that by instead of putting it on another line, by doing a colon, semicolon. Okay, so now we're in the PDB debugger. Okay, so set a breakpoint and drop to a Python debugger based on ipdb. I think I can exit out of here just by typing exit. I can, okay. So then this is just going to be ipdb and then ipdb. No module named ipdb. Okay, well, you know what? Let's do a pip install on that. Oh, and I installed it in my global space instead of my. So let's do a pip uninstall, and then we'll go into the file I had going for these projects. Which I guess I'm already in, and then we'll do a source vnv bin activate pip install ipdb, and now you can see we get these fancy graphs since I'm in a virtual environment. It's always better to be in a virtual environment. Things just work better. Okay, so now let's try ipdb. Oops, so something happened here. You know what? I wonder if what happened is... Let me try this. Oh, no, it did it right. It did it right. Yeah, I'm in PDB right now. It's just acting a fool. But I'm in it. I actually got in there. Although not technically a debugger, you can't move forward or backward in the stack. This one-liner allows you to start an ipython session when the execution gets to it. Okay, yeah, I was wondering if they wanted this to be in Bash. They're not clear about where they want this to go into, but I thought it needed to be in Python because they were using because it looks like Python code, so I thought they wanted it in Python. Oh. I'm not sure what the point of that was. Okay, I'm gonna install ipython in my virtual environment. I'm not sure if it's installed there yet. Okay, it looks good. Note, everyone seems to have a favorite debugger tool. We find PDB to be too rough. No auto-completion, no syntax highlighting, so we tend to like ipdb better. Don't be surprised if someone comes along with a different debugger. In the end, it's useful to know how PDB works, as it's the base needed to be proficient regardless of the debugger. In systems you can't control, use PDB directly because you can't install dependencies. You may not like it, but you can still manage your way around. How fast is this snippet? Python has a module to run a piece of code several times over and get some performance metrics from it. Lots of users like to ask if there are efficient ways to handle a loop or update a dictionary. There are lots of knowledgeable people that love the timeit module to prove performance. As you have probably seen, we are fans of ipython. I am too. I am a huge fan of ipython. I'm going to make another highlight. I'm going to highlight up till here so that, yeah. Just so I remember, just so that PDB pops up, because I never use PDB. I'm not used to using PDB, so I want to start using it more. Okay, and I don't need those old bookmarks. I only need my highlights, which will be in yellow. I think I have a note as well. Yeah, I have a note. But I only need yellow highlights. There you go. And then I need my bookmark for this page. How fast is this snippet? Okay. So as you have probably seen, we are fans of ipython, and its interactive shell comes with a magic special function for the timeit module. Magic functions are prefixed with the %sign character and perform a distinct operation within the shell. An all-time favorite regarding performance is whether list comprehension is better than just appending to a list. Two examples below use the timeit module to find out. All right, so let's follow along with this. Def x turn x times x. Okay, so I think, okay. In the standard Python shell or interpreter, you import the module and access it directly. The invocation looks a bit different in this case. I'm not sure what we saw there. I don't see a list comprehension. I guess I see one here, but it's not a list comprehension. Like, it's not, you would need brackets for that. What we're doing is we're saying for x in there, like it's not a, oh, here's the list comprehension. So I think we just haven't gotten there yet. I was expecting this to compare the list comprehension, but it looks like it's just giving us the result of what it is when it's not in a list comprehension. So hopefully later on we will see how much better it gets when it is part of a list comprehension. In the standard Python shell or interpreter, you can import the module and access it directly. The invocation looks a bit different in this case. Array equals this. Okay, so this is a non-list comprehension. Time it dot repeat pending from main. Okay, so we gotta import time it. There we go. Okay, so this is the non list comprehension. And this is how you would do this without using the magic method. You would need an extra import statement there to bring it in. So hopefully we get our results soon here. Here's our definition. So okay, here's our results. So let's try it for a list comprehension. And we should get much better results. It looks like there they got 5s. Mine's a bit slower. I've got 9s. But they got double the performance by using list comprehension. So I should get right around 4.5, and that's what I got. So you get about double for your book if you use a list comprehension instead of otherwise. So list comprehensions will cut your runtime in half. The output is a bit odd but that's because it's meant to be. Oh my god, I got the first shot of the vaccine. There actually is a little bit of muscle soreness associated with it. It's not bad at all, but like I'm starting to feel it a little bit. The output is a bit odd, but that's because it's meant to be processed by another module or library. It's not meant for human readability. The averages favor the list comprehension. This is how it looks in ipython. Okay, so let's try it in ipython. I thought we were already in ipython. I'm not sure what's going on here, but because ipython exposes timeit as a special command, notice the prefix with %sign. The output is human readable and more helpful to view, and it doesn't require the weird import as in the standard Python shell. I mean, it doesn't seem weird to me. I'm not going to highlight any of this. Let's keep moving. Strace. The ability to tell how a program is interacting with the operating system becomes crucial when applications aren't logging the interesting parts or not logging at all. Output from strace can be rough, but with some understanding of the basics, it becomes easier to understand what is going on with a problematic application. One time, Alfredo was trying to understand why permission to access a file was being denied. This file was inside of a symlink that seemed to have all the right permissions. What was going on? It was difficult to tell just by looking at logs, since those weren't particularly useful in displaying permissions as they tried to access files. strace included these 2 lines in the output. So permission denied. So I think these are the permissions here. The program was, oh no, these are the permissions, I think. Yeah, I'm not sure. Well, hopefully we'll find out. The program was setting ownership on the parent directory, which happened to be a link, and block.db, which in this case was also a link to a block device. The block device itself had the right permissions, so what was the problem? It turns out that the link in the directory had a sticky bit that's prevented other links from changing the path, including the block device. The chown tool has a special flag, -h or -no-deference, to indicate that the link in ownership should also affect the links. Okay, let's see if we have strace. For some reason, okay. Ah, we do have it. Okay, perfect. This type of debugging would be difficult, if not impossible, without something like strace. To try it out, create a file called follow.py with the following contents. It imports the subprocess module to do a system call. It will output the contents of the system call to ls. Instead of a direct call with Python, prefix the command with strace to see what happens. Okay, I get a bunch of garbage back. A lot of output should have filled the terminal, and probably most of it will look very foreign. Force yourself to go through each line regardless of whether you understand what is going on. Some lines will be easier to tell apart from others. There are a lot of read and fstat calls. You'll see actual system calls and what the process is doing at each step. There are also open and close operations on some files, and there is a particular section that should show up with a few stat calls. This system is pretty old, and Python in the output means Python 2.7, so it pokes around the file system to try and find the right executable. It goes through a few until it reaches /usr/bin/python, which is a link that points to Python 2, which in turn is another link that sends the process to user bin Python 2.7. It then calls stat on user bin module setup, which we've never heard of as Python developers, only to continue to the OS module. It continues to py-build-dr.txt and libdynlid. What a trip. Without strace, we would have probably tried to read the code that executes this to try and figure out where it goes next. But strace makes this tremendously easier, including all the interesting steps along the way with useful information for each call. The tool has many flags that are worth looking into. For example, it can attach itself to a PID. If you know the PID of a process, you can tell strace to produce output on what exactly is going on with it. Okay, so I'm going to highlight this part and move on. One of those useful flags is -f. It will follow child processes as they are created by the initial program. In the example Python file, a call to subprocess is made, and it calls out to ls. If the command to strace is modified to use -f, the output becomes richer with details about the call. When follow.py runs in the home directory, there are quite a few differences with the -f flag. You can see calls to lstat and readlink for the dot files, some of which are symlinked. Not only do calls to these files show but the PID is prefixed in the output, which helps identify which child process is doing what. A call to strace without the -f flag would not show a PID, for example. Finally, to analyze the output in detail, it can be helpful to save it to a file. This is possible with the -o flag. Okay, so I do want to take their advice and read it one line by line. I think that is going to be easier to do in a file though, so let's save this to a file. Oh. I'm missing an L. We'll highlight this as well. Okay, so now let's do a vi on output.txt. Okay, and we'll go through line by line and look at what happened. So, okay. Oh, that's interesting. Oh, okay, never mind. I thought mmap was the custom function I made, but I don't think it is. It's closing something. Yeah, I don't understand any of this. Now, was this done with the -f flag? No. So I'm not going to get like the process ID or anything. Huh, I'm confused. Well, I am going to highlight that though because this might be valuable to keep in mind. So let's go through the exercises. We're going to define what IOPS is. I have no idea. Let's Google it. So IOPS is the input-output operations per second. Explain what the difference is between throughput and IOPS. Yeah. So IOPS measures the number of read and write operations per second, while throughput measures the number of bits read or written per second. If you have small files, there will be more overhead. So while IOPS and throughput look good, you may experience a lower actual output. So let me try to think about what this actually means. So IOPS measures the number of read and write operations per second. So the number of times something has been read or written. But throughput measures the number of bits read or written per second. So I guess you can think of it like this. If you were to read a book, or like these videos here that I'm making, like an IOPS would measure the number of videos that I made. But the throughput would be like the total time of all the videos. So like, let's say I made 100 videos. That would be an IOPS measurement because that's the measurement of a video making operation. But let's say each video was 100 well, each video was 1 minute long. So the throughput would be one minute per video. So it'd be 100 minutes for all of my IOPS operations. So they're different things. I think this hopefully explains it clear enough. IOPS measures the number of read and write operations per second, while throughput measures the number of bits read or written per second. So operations versus the actual results of the operations. IOPS measures the operations, throughput measures the results of the operations. Name a limitation with fdisk for creating partitions that parted doesn't have. I mean, I don't know. I don't know. So fdisk limitation parted doesn't have. Oh, so it looks like parted can show extra partitions. So it looks like fdisk. Looks like parted is for, yeah. So a limitation with fdisk is the drive has got to be less than 2 terabytes. So you can use parted for bigger drives. So you can just use parted, or you can just use fdisk, but if you're using a bigger drive, you've got to use parted. At least is what they're saying here. I'm not sure if that's what they're trying to get out of from here. Okay, but next let's name 3 tools that can provide disk information. Let's go to the table of contents. This was chapter 4, I believe. Three tools that can describe disk information. There's a CPU utility. Here's chapter 4. Oh, here we go, disk utilities. Oh, here's what the book says about throughput or IOPS. Okay, it just says the same thing. IOPS is for input-output operations. Throughput is for the actual bits read during those operations. Okay, here we go for retrieving. Okay, so here we go. We can use lsblk or blkid. So that's 2 of them. What's the third one? I don't see a third one. I guess I'm not sure what they're getting at for the third one, but it looks like 2 of them are ls blk and blkid. I guess fdisk is the third one. You can use that as well. So I think that's probably what they were getting at for that third one. Oh, we got some more questions here. So what can an SSH tunnel do? When is it useful? So an SSH tunnel can allow you to use a like develop a web app and view it like over. Let's see here. So can an SSH tunnel do, and when is it useful? Okay, so an SSH tunnel creates a secure connection between a local computer and a remote machine through which services can be relayed. Because the connection is encrypted, SSH tunneling is useful for transmitting information that uses an unencrypted protocol. So let's say that on my, like for example on this machine doesn't have a like I can so let me see here. So the keywords here is through which services can be relayed. So an SSH tunnel can allow you to relay a service through it, and basically like when you SSH to a computer and you have a command line for that computer, you can also access other things. Like if you're developing a web application, you can like send it over the SSH tunnel and then open it up in your browser instead of on the browser of the computer where you're developing it on. So yeah, so it's useful for development. Another thing it's useful for is encrypting unencrypted protocols. You can send them through an SSH tunnel and you don't need to be concerned about the fact that they are unencrypted. Okay, next is a case study question. Create a load test using the molotov tool that sends a JSON response from a server with an HPE status of 200. I might skip this one just because, well, you know what? I think I can do this. So we're going to use molotov. We're going to do a JSON response. I think we already did this. So we can basically just go back and do exactly what we did. Yeah, load testing with molotov. So this is basically what we did. Yeah, this is the exact same thing. So I guess I'll just type this out again, and then that will be the answer to that case study there. In fact, I still have it, so. Okay, so let's create a Flask application. And I think I have the Flask application as well. Yeah, so if I started with Flask app equals small.py. What? Oh. There we go. Okay, so now I can do the test. So I can do molotov -v -r 100 load test.py. Okay, well, I don't know what happened here, but But anyways, I think that's what they were getting at. They wanted me to do that. This whole section is kind of off the top of my head. I mean, this is a DevOps book, and I'm more kind of in network engineering, which doesn't seem to be exactly the same thing. So this section I don't think has been super relevant to me so far, so I'm just going to skip it. I'm going to skip this case study question. I mean, we did it before, and it seemed to work before, so I'm not going to spend a lot of time on it. And then this I think will be better package management. But that's going to be in the next video. So this was the end of chapter 4. I will see you in the next video where I dive into chapter 5.